And welcome to the last part of section 4.3. My name is Gregory Carlson. In the previous video, we looked at how to break up a bunch of logs, or if we had a log that had a really complicated argument, we figured out how to break it up into pieces. So you can guess what's going to happen next. We're going to take something that's broken into a lot of pieces and form it back together into one log. So it says rewrite the following so that there's only one log, or so that the number in front of the log is equal to 1. So fortunately, this is kind of straightforward if you know your log rules. Again, this is dependent on you knowing the log rules. So please make sure you memorize them. Essentially what we're going to do here is going to go backwards compared to what we did in the previous section. So for example, you see how I have 5 times the log of all of this stuff? That means I can take this 5 and move it upstairs and move it up there. So this becomes log 3. There's nothing we can do when there's adding inside of the log, so don't even try. It's only when we're multiplying or dividing in there. Anyway, the 5 can come up to here, just like that. So now let's put in the plus, and likewise we can take this 2 and put it up there. So here's log base 3 x plus 1 to the 2. So that's the power rule kind of in reverse. Now, I notice we have a plus here, and I notice that we have a base 3 and a base 3. So now we can use that multiply rule and do it in reverse. Log base 3, and now just multiply the arguments together. And in fact, now you're done, because all of this is in one set of parentheses. We only have one log, and there's a 1 right there. So here's your final answer. And don't get thrown off by me using square brackets. Those are just, if you want, you can just use regular parentheses. Now, I can only do this step. If these bases are the same. So if these bases are not the same, then there's not much you can do, okay? All right. Now let's do this example. In fact, why don't you try to do this one on your own before we do it together. So pause the video here, see if you can get this one on your own. Did you do it? Here we go. First, I would move the 6 up and the 3 up, because that's what you can do if it's multiplying. So that first one becomes log base 7 of y minus 4 to the 6th power. And that would be a lot of foiling if you wanted to multiply that all out. Minus log base 7 z plus 4, and then that's to the 3. So that's minus log base 7 z plus 4 to the 3, because the 3 just came upstairs. Unlike the previous example, I notice we have a minus here, so that means that we can use the division rule. So here's the final answer. Log base 7. On top, we have the positive piece. And on the bottom, we have the negative piece, the negative sign. So, in order to be proficient at this, you need to be able to go from here to here and work backwards to go from here to here. So if you can do both of those in both directions, then you're in good shape. And again, notice this is just one giant argument, one log, coefficient of 1, so you've satisfied the requirements. One last example, let's do it. They tell us that log base 10 of 5 is equal to this decimal approximation, and log base 10 of 3 is equal to this decimal approximation. So find log base 10 of 25 over 9. So if you had a calculator, you can find it, and let's go ahead and cheat and just plug it into the calculator. 25 divided by 9 equals, and then take the log of that. So that's the answer, but let's see if we could do that if we didn't have a calculator. So we know what log 10 of 5 is and what log 10 of 3 is. So what I would do is I would start by taking log base 10 of 25 over 9, right? And I notice that I could rewrite that as log base 10 of 5 squared over 3 squared. Do you agree with me on that? Because we're trying to get this so that we only have 5s and 3s. So now we can rewrite this as log base 10 of 5 squared minus log base 10 of 3 squared. right? I'm just following my log rules. And now finally, we have one more thing we can do. We can bring down those powers. So 2 times log 10 of 5 minus 2 times log 10 of 3. And now that we've done that, now we can do this without a calculator. So in other words, it'll be 2 times, they tell us that the log base 10 of 5 is 0.6990 minus 2 times log base 10 of 3 is 0.4771. So if we crunch that on our calculator, we should get an answer. So I'm just going to write this number up at the top. Let's see how close we get. 443697499. All right, so let's do 2 times 0.6990 is 1.398 minus 2 times 0.4771, 0.9542. So let's subtract those. 1.398 minus 0.9542 equals. And we get 0.4438. So that's pretty close to what the calculator gave us, which was 0.4437 if you round. So 0.4438, that's pretty close. Now you notice that if we don't have log base 10, we're really stuck. There's not much we can do with the calculator, and so that's why in the next section we're going to learn what to do if that's the case. I want to close this section with this. Remember, log of xy equals log x plus log y. That only works if the argument is x times y. If you have the log of a times the log of b, that does not simplify. So don't try to force this to simplify. This is not log of a plus b. There's nothing we can do with this because it's only the argument that's multiplying that breaks into log of x plus log of y. If this was log of a plus log of b, then we could simplify it, but it's not. Likewise, if I have log of c divided by log of d, that does not simplify. That's not log of c minus log of d. So it's really important. So these two right here do not simplify. So don't try to force them to. It only simplifies if they follow these rules we went through. So please make sure you can actually apply the rule before you simplify. All right, we are done with 4.3. I will see you in 4.4. If this video was helpful, please make sure you like and subscribe. If you have any questions, please leave them in the comments. See you in 4.4.